Today we will start with a new chapter, that is physical and chemical changes. Friends, in our daily life we see changes around ourselves, around our home, environment, everywhere. You must appreciate that. For example, growth of a tree, rising of a sun, setting of a sun, burning of coal, say paper, wood, etc. Now, before we go into physical and chemical changes, understand their scientific meaning, it is very important to understand few terms, which are physical properties of a substance, chemical properties of a substance, reversible process and irreversible process. I will explain all these four terms with help of an example for each. We'll start with physical properties of a substance. The shape, size and state of a substance are termed as physical properties. For example, if you take a sheet of paper and if you try to fold it in form of say cube, rectangle, cylinder, etc., etc., then what is happening is you are changing the shape and size of the paper, and if you unfold it, it will be again into the form of the same paper. Correct? It means you can change shape, size and state of a substance, and those are called as physical properties. Whereas if you talk about chemical properties of a substance, then the internal properties of that substance are termed as chemical properties. For example, suppose you take two beakers. In the first beaker you place say 100 ml of milk, and in this second beaker you place say curd from the same 100 ml of milk. If you see from the top, both are white, both are of the same shape because the bowl container is same, of the same type. But actually the curd which is formed from the milk has different internal properties from the milk. It means the internal properties of a substance are called as chemical properties. Now if you talk about reversible process, see, if you try to apply some force or some try to change some substance, and the substance can be retrieved back, which means the process which can be reversed are called as reversible process. If you take the same example of say that sheet of paper, if you suppose this is your paper, suppose consider my hand as the paper. If you try to fold this paper like this, you can again unfold this paper. Although you can see while unfolding, you can see a line there. It is a reversible process, although you can say it is not 100% reversible because originally there was no line, that because of folding it had been created. But still it is a reversible process. Now what are irreversible process? Exactly opposite to the reversible. You can get that from the word itself, irreversible. Those processes which cannot be reversed back, which means you cannot have the substance back as it was original when undergone a process, are called as irreversible process. See, we have seen that example of milk a few moments ago. Again I will take the same example. If you form curd from a milk, from some amount of milk, you cannot have milk again back from that curd, which means this process is irreversible. Correct? So these are a few examples of different terms which we have seen for physical properties, for chemical properties of a substance, reversible process and irreversible process. Now we actually move into changes. See, changes are of two types: physical change, chemical change. What are physical changes? When the physical properties of a substance do not change and the body or the substance can be retrieved back, then the process is called as physical change. Now I said the substance can be get back again, retrieved back again. It means that process is physical change with reversible process. Correct? Although if you talk only about physical change, it means when the properties of a substance remains same and it does not change, then that change is called as physical change. Correct? We have seen that example of paper also. Now to illustrate, we have many examples of physical properties. We'll start with say folding of a sheet. Now if you take a paper sheet Suppose you form suppose you consider my hand as the sheet of paper and you try to form a cylinder, say. Now you have changed the shape and size of this paper. You can unfold it. So you can say that this process is reversible and the change is physical. The properties remain same. It was paper earlier also and now also. Properties are not changing. Okay? Another example, see cutting of a piece of a paper. If you cut a piece of paper into different small tiny pieces, then every tiny piece is again a paper. Although it will be obviously difficult to form again the same sheet of paper from those tiny pieces, but the properties have not changed. Those tiny pieces are still paper, and the earlier a single form of sheet was also paper. So it is again an example of physical property. If you talk about say different processes like melting of an ice, say you have a cube of ice, you have taken it out from your freezer, you try to melt the ice. You have changed the state of water. Earlier it was in the form of ice, a solid. Now it is in the form of a liquid, but the water remains same, right? And also that volume of water, that amount of water can be again freezed in the form of ice cube. So it means this example of melting of an ice is actually an example of physical change, and it is a reversible process also, correct? Also, if you talk about say melting of a wax, so if you have a candle, you are trying to melt the wax. What happens is, you can melt the wax, it will be converted into liquid form as long as it has heat. But you know that you have experience in your day-to-day life in say on Diwali, or if you don't have say light in your house and you try to light up candles. What happens is, you can see the wax is melting, and again as it goes down it solidifies to form wax again. Okay. Now it was wax earlier also, it is wax now also when it has been converted again from liquid to solid form. Again it is an example of a physical change, correct? And also it is a reversible process. Do remember, burning of wax is far different from melting of wax. I am talking about melting of wax. Okay? Now if you take another example, say you take vaporization. Suppose you have a closed container and you have kept some amount of water in it. If you heat that water, obviously vapors will be formed, and this process is called as vaporization. Right? Now you have changed the state of that liquid water you have taken. For example, water you have taken. You have changed the state of liquid, state of water from liquid to gas form, but again it is water only. That vapors can be again condensed to form the same volume of water. Why? Because the container is closed. Obviously, if you keep the container open, then what will happen is that vapors will go into air, and you cannot get back the same volume or the amount of water. So we have taken the example of a closed container having some amount of water. Now this was vaporization, and the second process where vapors are being converted into a liquid form of water, then that process is called as condensation. Again you have changed the state from gaseous to liquid. It is a physical change, and the process is reversible. Okay? So these were few examples. Also, if you try to figure out, there are many examples in your day-to-day life which tells us that it is showing us physical change and not chemical change. We have not seen chemical change yet. Now we will come to that. We are talking only about physical change as of now. Also, if you try to take an example of say rubber band, I mean you have seen in your day-to-day life, you play with rubber bands. If you try to stretch that rubber band, of course the constraint is in elastic limit. If you try to stretch that band, what will happen, as you remove your finger or as you remove that force, it will again regain its shape, correct? Original shape. It means the change you brought to that band, rubber band, is actually a physical change. How you have changed the shape and size of that rubber band. And since it has been again converted or it has been again retrieved into the same shape and size, the process is reversible. So these were the few examples which we have seen, which tells us that shape, size and state concerned with the substance are physical properties, and when these physical properties do not change, then the change is called as physical properties of substance do not change, then the change is called as physical change. Now we'll come to chemical change, the second part of change. Chemical change is a change in which the properties of a substance do not change and no new substance are formed. Correct? Whereas if we talk about chemical changes, then properties of a substance changes and new substances are formed. Now chemical changes can be reversible also, irreversible also, but most of the time you will find it irreversible. But even if you talk about reversible chemical changes, then also new substances are formed. Okay, now we will understand chemical changes with few examples. For example, burning of coke, say coal. Coke is a form of coal. So if we take the example of burning of coal, you can see the reaction when C represented for carbon, coke, coal, C reacts with oxygen, it forms carbon dioxide and water. When the supply of air is excess. In limited supply of oxygen, carbon burns with air or reacts with oxygen to form carbon monoxide and water. Now, left behind is ash, correct? If you burn coal, you can see ashes formed. Now, if you can you combine carbon dioxide, water and ash to again form coal? The answer is no, you can understand that. So you see in this example of burning of coal, coal reacts with oxygen to form new substances, correct? And the property of coal vanishes. Left behind is ash, liberated gases, carbon dioxide and also water in form of vapors. Water cannot be formed in liquid state because obviously it is acquiring, it is taking in heat, and water form will be liberated in form of vapors. So new substances are formed, properties of the substance changes, and this process is reversible or irreversible. This process is irreversible. Why? Because you cannot combine again carbon dioxide, water and ashes to form coal back. Correct? Now similarly, if you see burning of different fuels, say paper, wood, anything, you can say the properties of substance changes and more new substances are formed and the process is irreversible. Obviously, if you talk about wax, if you remember, we have seen that in physical changes, if you talk about wax, I have given a statement, I am not talking about burning of wax and melting of wax. This time I will explain you how burning of wax is a chemical change and melting of wax is a physical change. See, if you take a piece of wax, or candle for example, and you try to burn that wax, then that wax liberates into in form of gas into air and cannot be retrieved back to form that wax again. It is a chemical change. The properties of that substance has been changed and new substance has been formed. Whereas if you talk about melting of wax, and if you melt a piece of wax in liquid form, it again solidifies to form that wax back. So the process is physical change and also it is reversible. Now to understand chemical changes, we will see different type of reactions. For example, we will talk about reaction of vinegar with baking soda, where vinegar is actually acetic acid CH3COOH, and baking soda, which we see in our households also for formation of cake, bread, different stuffs, we use baking soda. That baking soda is actually sodium hydrogen carbonate, NaHCO3, or you can say that sodium bicarbonate. We'll see the example of burning of a magnesium ribbon also. Let me tell you, I will illustrate that further also. Magnesium ribbon burns with a dazzling white flame. That is the characteristic color of magnesium while burning. We will also see the example of the reaction of copper sulfate solution with iron. We will see how rust is formed on the surface of iron, that is rusting of iron, and also try to figure out how we can prevent rusting of iron. Now friends, before we go into these 4 different type of reactions and also study how we can prevent rusting of iron, let me tell you a small story about rusting of iron and how that rusting of iron eats the parent metal, whereas it does not happen with different metals. If you see, if you go to a museum, say for example, you will find, if suppose take any warrior, say for example you take the great Rana Pratap. If you go to the museum of the great Rana Pratap, you will find they have kept the utensils or containers, and the guide says, or the person standing there says, this utensil is the same utensil, or the container is the same container in which the food was cooked for the great Rana Pratap, or this plate is the same plate on which he used to have food. Correct? You might have observed that. The reason is that particular container or the plate has been kept for so long, so many years, is because those plates or container were made of aluminum, brass or copper. Now, if suppose that plate was made of iron, then will you believe that that plate will be can be kept for so many years? The answer is no. I will explain you why. See, when iron comes into contact with air or water or the humid environment, it forms iron oxide. But that iron oxide, which we call as rust, is actually a powdery form, and if you rub that piece of metal, iron metal, that rust or the powdery form of iron oxide comes out from the surface, and the inner part of the surface gets exposed to the air and it starts to form iron oxide, or it starts rusting. Correct? But if we talk about aluminium, aluminium also react with oxygen to form aluminium oxide. That is corrosion of aluminium metal, rusting of aluminium metal. But that aluminium oxide sticks to the parent metal and cannot be removed easily, and it prevents the parent metal to be rusted from the humid environment. This is why those utensils or those containers can be kept for years, until you keep rubbing them and remove the aluminum oxide, then the parent metal, the parent aluminum metal will be exposed to the humid environment and will be corroded. Now this is why iron gets rusted easily, because it forms a powdery substance which can be removed from the surface and the inner part gets corroded. Also, obviously I was just trying to explain the rusting of different types of metals. We will see these reactions, that is reaction of vinegar with baking soda, how magnesium ribbon burns, how copper sulfate reacts with iron, and how rust is formed for iron, rusting of iron, and how we can prevent the rusting of iron. And the story which I have just told you about iron metal and aluminum metal, that utensils or the container kept in museum, that is actually what happens. Also, you would appreciate that aluminum oxide is actually poisonous. This is why you find utensils and containers vanishing from our kitchen over the years. Nowadays, you will find plates made of ceramics, glass or stainless steel, or maybe plastic. But we have stopped eating food in plates of aluminum metal. Why? Because that layer of aluminum oxide is actually poisonous. If you have seen movies, Hindi movies or English movies, older Hindi movies, English movies, which were made earlier in say 50s or 60s, you will see the containers or the utensils made of aluminum. But slowly people started to realize with the research, and the scientists also started to realize that aluminum oxide is poisonous and were removed from our households purposes. And plates were made of stainless steel, plastic, ceramics, and so this is what I was trying to explain, rusting of different metal. Now we will proceed with different examples and understand what are chemical changes and how it takes place with these 4 examples.
No more spending your energy and money on coaching classes, or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
So we will start with the first reaction, that is reaction between vinegar and baking soda. Vinegar is CH3COOH, that is acetic acid, whereas baking soda is NaHCO3, that is sodium hydrogen carbonate, also called as sodium bicarbonate. Now, before we see the reaction, you might have heard and seen also in your households that baking soda is used or baking powder is used. See, I will explain the difference between baking soda and baking powder, but you might have seen baking soda or baking powder is used to add while making cakes and bread. Why? To make that stuff fluffy. I will explain you how that is formed. First we will see the reaction. CH3COOH reacts with NaHCO3 to form carbon dioxide, water and sodium acetate, which you can see here. CH3COOH plus NaHCO3. CH3COOH is your vinegar, acetic acid. NaHCO3 is baking soda, sodium hydrogen carbonate, better known as sodium bicarbonate, forming carbon dioxide, water and sodium acetate. Now, when vinegar reacts with sodium bicarbonate, that is your baking soda, carbon dioxide gas is released, correct? Because of that release of carbon dioxide, the stuff becomes, fluffy, and that is why baking soda or baking powder are also called as leaveners. Now, how to check whether the gas is carbon dioxide or not? If you pass this carbon dioxide gas into lime water, that is calcium hydroxide, you see this reaction, calcium hydroxide reacting with carbon dioxide to form a white precipitate, that is calcium carbonate, and also water is formed. Correct? Now this is a specific test to determine whether the gas is carbon dioxide or not, because obviously you cannot taste, you cannot see carbon dioxide. Carbon dioxide is tasteless, odorless, you cannot smell even. Correct? So this lime water test is specific for carbon dioxide. So again we see vinegar reacts with baking soda to form carbon dioxide, water and sodium acetate. Correct? Now I was talking about baking soda and baking powder. See, both baking soda and baking powder are leaveners, but chemically they are different. Baking powder is actually a mixture of baking soda, that is your sodium bicarbonate, and a dry acid. For example, cream of tartar. If added to baking soda, then that is called as baking powder. Now, suppose you have baking soda or baking powder in your households and you want to check whether it is still good or not. It has been kept for so long time in your kitchen, whether the stuff is good or not, whether it can be used for making cakes or breads or whatever it is good or not. For baking soda, what you can do is you take a bowl, pour that baking soda into it, and you add some vinegar into it. If bubbles comes out from it, which is actually that carbon dioxide, we have seen that in the reaction. If the bubbles comes out from that bowl or the solution of vinegar and baking soda, then the baking soda is still good. Whereas to check baking powder, where baking powder is actually a mixture of baking soda and some dry acid like cream of tartar. Again you take a bowl, pour some amount of baking powder into it and add some water into it. If foams are formed, if foams are formed, then that baking powder is actually good and can be still used. So we have seen reaction between vinegar, which is an acid, CH3COH, acetic acid, and baking soda, that is sodium bicarbonate, which you can also call as sodium hydrogen carbonate, NaHCO3. It has sodium also, hydrogen also, and carbonate CO3. That is why it is called as sodium hydrogen carbonate, that is sodium bicarbonate. And it forms carbon dioxide, bubbles of carbon dioxide are formed, water is formed, and also solution of sodium acetate. Now moving further to the next reaction, that is burning of magnesium ribbon. Suppose you take a magnesium ribbon and hold it with a say pair of tongs, and you keep a plate below that magnesium ribbon and you are burning that magnesium ribbon. What happens is, you can see the reaction. What happens is, magnesium reacts with oxygen to form magnesium oxide, and while burning it gives a dazzling white flame. That is a characteristic color of magnesium. Now that ash, the powdery ash collected in the plate kept below that burning magnesium ribbon is actually magnesium oxide. If you dissolve that magnesium oxide into water, it will form magnesium hydroxide, which is actually a base, basic in nature. How to check whether it is a base or not? You can use a litmus paper. If you dip a red litmus paper into solution of magnesium hydroxide, it will turn into blue color, indicating that magnesium hydroxide is actually a base. So these were the two reactions which we have seen so far. Let me tell you that sodium bicarbonate, sodium hydrogen carbonate, which we have seen in the first reaction of vinegar reacting with sodium bicarbonate. You know, solution of sodium bicarbonate is also a base. In that reaction, acid and base were reacting. Sodium bicarbonate is also a base. You can check whether it is a base or not with the same red litmus paper. If you take a solution of sodium bicarbonate in a beaker and if you dip red litmus paper into it, it will turn into blue color, indicating that it is a base or basic in nature. And similarly, magnesium hydroxide also turns red litmus paper into blue color, indicating or telling us that it is basic in nature. Now, moving further, we will see the third type of reaction, that is reaction of copper sulfate with water. Correct? Suppose you take a test tube, you pour some copper sulfate and add some water into it, and you make a solution of it. That solution will be blue in color. Copper sulfate solution is actually blue in color. Also, before seeing this reaction, let me tell you, anhydrous copper sulfate. Anhydrous, the word anhydrous means it does not have any molecule of water into that crystal lattice of copper sulfate. Anhydrous copper sulfate is actually white powder, but when you dissolve it into say some amount of water, it will form a blue color solution. Why? Because it becomes hydrous copper sulfate, and there are fixed number of water molecules. In case of copper sulfate, it is 5 water molecules, 5 H2O. Now there are fixed number of water molecules which associate with every crystal lattice of any compound, and that number of water molecules is actually called as water of crystallization.